So in 6.1, we looked at circles in general. And in 6.2, we're going to look at specifically what's called the unit circle. So the unit circle is a circle centered at the origin. So it has location in space, and it has a radius. Yikes. Pretend that's a circle. It has a radius of exactly 1 unit, whatever units you're measuring in. So this would be 1 centimeter or foot or mile or whatever, but 1 unit. And you might recall the equation of circles centered at the origin is x squared plus y squared equals r squared. And if the radius is 1, then r squared is also 1. So every point on this unit circle is going to fulfill this particular equation. And some of those are easy to see. We know points like this point right here. It's going to be 1 over and 0 up. So 1, 0, and 1 squared plus 0 squared does indeed equal 1. And there's a few other points that are pretty easy to figure out. That's 0, 1, and this is negative 1, 0, and this is 0, negative 1. There's other points that take a little bit more sort of geometry, mucking around with geometry to figure out. But we can figure out a few of those too. So it turns out this point right here, that's halfway through the first quadrant, happens to be square root of 2 over 2, comma, square root of 2 over 2. And there's some others. And we can associate all of these with their degree or radian measurements. So for instance, this point 0, 1 right here, you would be at that point if you were at 0 degrees around the circle, or 0 radians. And this point here at the top, you would be at 0, 1 if you were at 90 degrees, or pi over 2 radians. And likewise, this one over here would be 180 degrees, or pi radians. This one at the bottom would be 270 degrees, or 3 pi over 2. This one here that's halfway around the first quadrant, is halfway between 0 degrees and 90 degrees, 45 degrees, or also halfway between 0 and pi over 2. I would put it at pi over 4 radians. Okay, so there's actually 16 points around the unit circle that we're going to know these exact coordinates for. And I'll post this on Canvas, but these are the 16 points. And before this course is done, you are going to have all 16 of these memorized. Yay! Matter of fact, the first question on the final exam, I'll just tell you flat out, the first question on the final exam is exactly this unit circle with blanks instead of numbers. And you are just going to fill in every single XY coordinate and every single radian measurement. I don't think I asked for degrees on the final exam. You should be comfortable with both, but I think the final exam just says X coordinate, Y coordinate, radian measurement for all of these 16 points. And don't worry, I'm going to drill this into your head so hard that you are going to memorize it whether you want to or not. Okay, so let's talk about the 6 trig functions. So these 6 trig functions are ways to talk about points on the unit circle. The first of the 6 trig functions is sine, and it's a function, so we'll use this function notation. So the input will be t. And sine of t is just defined to be the y coordinate on the unit circle. So I could literally ask a question like, what is sine of 5 pi over 6? And you would go back to your unit circle, which you will have memorized at some point, but for the moment, we'll just look at the unit circle and say 5 pi over 6 is right here, and the y-coordinate is 1/2. So sine of 5 pi over 6 is exactly 1/2. So there's 6 of these trig functions. Sine and cosine are the most basic ones. Cosine is the x-coordinate. And the other 4 are all based on some combination of the x and y coordinates. So we have tangent, which is the y-coordinate divided by the x-coordinate. We have cotangent, which is just the flip of that, is the x-coordinate divided by the y-coordinate. We have secant, which is 1 over the x-coordinate, and cosecant, which is 1 over the y-coordinate. And question number 2 on the final exam is just going to be these 6 trig functions, and you are just going to write out sine is y, cosine is x, tangent is y over x. You're just going to write these 6 definitions. So knowing those 6 definitions and knowing the unit circle, you should be able to do anything like, say, cosecant of 4 pi over 3. And so first of all, you remind yourself that cosecant is 1 over the y-coordinate. And then you go back to your unit circle and you take a look at 4 pi over 3. And you say, okay, on the unit circle, 4 pi over 3 is right there. The y-coordinate is negative square root of 3 over 2. So 1 over negative square root of 3 over 2. That is the cosecant of 4 pi over 3. We'll probably want to simplify a little bit. So 1 over a fraction flips the fraction, so it's 2 square root of 3 negative. And they'll also want to rationalize the denominator, which I'm sure you remember rationalizing denominators, but the basic idea is to, if you have a square root of 3 on the bottom, is to multiply by 1 in the form of square root of 3 over square root of 3, so that the bottom simplifies into something that doesn't have a square root. So square root of 3 times square root of 3 is 3, and the top will be 2 square root of 3. So ultimately, when you type your answer into MyMathLab, cosecant of 4 pi over 3 will be 2 square root of 3 over 3. So those 16 points around the edge of the unit circle, you should be able to give exact square root sorts of answers for. If they ask for the cosecant of not one of those 16 points, then you'll just grab your calculator and you'll have to give an approximate answer. So you can't give an exact answer for every point on the unit circle, just for those 16 that we know. Okay, that's a quick intro to the unit circle and the 6 trig functions.